In this video, I explain how we define data in MASM. You understand that the version of the assembly that is going to be taught in this book, in this course, is MASM, Microsoft Assembler. So, well, my computer is a Mac M2. The only option that I have is to connect to internet through using my VDI. So virtual desktop environment. But I connected. This is my virtual desktop environment. The first thing that I need in order to work in this environment, I need to have a version of the template. So I'm going to go to Windows. I'm sorry, I go to, where's this? So I go and I download the no. So I will download the library that I need. Well, I need two items. One is needs to be installed on the Z drive, and there are on the C drive, and there are the Irvine library. I have them. So there's only one item that it is missing in here on my desktop. So I want to go to my desktop, and I need to have, or somewhere else, I need to have, so let me see that if they have downloaded, I'm sorry. So this PC, so let me see that if they have this 32-bit library. So it seems that they don't have it. They have not downloaded the 32-bit template for us. So what I do, I go to the template or go and download the template. So asmirvine.com. So I'm going to go for Windows 2022, which is by school. Then I go to GitHub. And I'm going to go with this Project 32. If you don't have Project 32, then you are going to have a hard time. So what I do, I'm going to go and download it. And then I'm going to put it on my desktop. I'm going to go and extract all. I don't need the zip file, so I'm going to go and download it. I don't know how they can delete, so it seems that there was a way, I just forgot. So now I need to have, in order to be able to do assembly, I need to have Visual Studio. So I'm going to go and open what is installed on VDI. So Visual Studio 2022. I will not start So I'm going to open a project or solution. I'm not going to go and start a new project, because if I want to do a new project, I have to do a lot of setting, and I don't want to do it. So open a project or solution. Well, the project or solution that I have, it is on my desktop. So I go and I open that project or solution. So this is the project. I'm going to open it. That's it. This is my template. Well, if you see that, it is asking me, do you want me? Well, I don't want really, because I don't want to do anything in my account. So here is the template. Well, those are the template items. So I have to copy and paste. If you want to see what are those things, please refer to your textbook and see what are those things. This is the return function. So in order to end, you're going to invoke. That means you're going to call this function, which is exit process. And this is the parameter that you're going to pass. That's the argument that you're going to pass, and it is 0. 0 is of this type. So the variable name inside that function is DW exit code, and it is of the type double word. So here is my environment. I want to add a bunch of item in here. So I want to have a data. It is called a segment. Any segment in my program starts with .data. So on my .data segment, I want to have a different data type. So what are the data types that we can have for this for MASM? Those are the data types. So I can have byte or SByte. Well, it is a name, and well, it explains that each label, it is called as a label, the variable name. So let's call it as var1. Well, it can be combination of A to Z and numbers and $sign and underscore, I believe. So var1, but it can't start with a number. It is like variables in other high-level programming languages. It can't start with a zero or with a number, I'm sorry. So type goes with some space in here. So I can have byte. You can write it in all capital or lowercase, doesn't matter. Doesn't matter. The Microsoft is case insensitive. And then the value. Value could be decimal, could be binary, could be hex. So let's put the value of 2 in here. So var1 is going to have the value. So it is a place in the memory, in the segment in the memory called as a data segment, where I refer to that location in the memory with the name var1. 1 byte of the memory is referred by var1, and I'm going to hold the value of 2 at that location. So I'm going to go and do some, here is in .code is my assembly. So in here, I can have instructions. Well, one of the very famous instructions is move. And move means a copy. So I'm going to copy from to. Well, the first parameter is the to, which is destination. Destination could be another memory, or it could be a register, but it has to be of the same size. So let's say it is 1 byte and it is var1. So I'm going to copy from the memory location var1 into AL. Now let's run this piece of code and see that if it works. In order to run, there's 2 steps. One is to build. So I'm going to run rebuild the solution. So rebuild is good. Always use the rebuild the project or rebuild the solution. So it says that you have 1 file. Yes, this is the file. And it is this. No, I want to make a change. I don't like this name. Right click and say that rename. So any other name or F2. So you can put any other name. The assembly code is going to have extension of .asm. So you build and say that once successful, yes, you had 1 file and successfully it is assembled. Now, if you want to debug or if you want to run, if you run, there's nothing in here really to run. So I have to see inside my code, I have to debug. In order to debug, you need to go to this ribbon in here and you need to have a breakpoint. The breakpoint has to point to an instruction. So you see that it is pointing into an instruction. Now I have to build it again because this time I want to build for the purpose of debugging. Everything good? Now I'm going to go and start debugging. Debugging means it is going to show you inside the code. If you want to, right now you see that this arrow is pointing to this location. That means I am going to point to this special location. Well, but it is not yet run. So in order to run, you're going to go and say that to debug, you say that step over or F10. Oh my goodness, it is done. So F10 has executed the instruction move AL var1, that means copy from var1 into AL. AL is a register of size 1 byte. So you don't see anything in here. Well, I want to see inside. In order to see inside while you are in the process of debugging, go into debug Windows and say that I want to see registers. So you go to Windows, and then from Windows, you're going to go to the end and say that, well, I want to see the registers. Now you can see inside the registers. So if you want to see that what happened in AL, which is this portion of EAX, you have copied the value of 2. Let's do, you understand that every 2 hexadecimal character is every 2 hexadecimal character is 1 byte. So I can say that, well, I want to have FC hexadecimal. But there is a problem. A hexadecimal number can't start with a non-numeric symbol. It can't. It cannot start with FCH, with F. Let me run it and see that if I am right. So I'm going to rebuild this to see. It says that you want to terminate the previous and say yes. So you see that you got an error. The error says that undefined symbol FCH. It doesn't understand because FCH is a label. It starts with a non-number. So in order to say that, well, this is a number, you put a 0 in front. So nothing will change, but it is not anymore a label because a label can't start with a number. Now, if I build, you're going to see that everything is going to be good. Oh my goodness. So in your test, if you define a number and it doesn't start with 0, you can see that it is an error. This is a programming language. It is not concepts. It is a language. So if you don't put 0 in front, then you're going to get an error. So let's see that what other kind of destination I can have. Since the source is a memory, then destination has to be a register. Memory to memory is illegal. So let's do this. I'm going to define another variable. I call it as var2, and it is byte. And I want to do this. Well, it is not initialized. That means if I put a question mark, that means it is not initialized. So I want to copy from var1 into var2, from memory to memory. You're going to see that it is an error. Memory to memory is illegal. So build, I'm going to rebuild. Oh my goodness, you see that tons of errors in here. Memory to memory, it is illegal. So how can I do it? It has to go to a register of size 1 byte. Oh, no, I want to do 2 bytes. What is wrong with this one? var1 is 1 byte. I want to place it in 2 byte. Well, in larger space. No, it is not acceptable because you're talking to hardware. And hardware has to know what you want to do with extra byte. So let me do this. Oh my goodness, error. The reason is instruction operand must be the same size. Oh. So any register of size 1 byte, well, it could be AL, it could be AH, it could be BL, it could be BH, it could be CL, it could be CH, it could be DL, it could be DH. So let's use DH and see that what will happen. Oh my goodness, I have no problem. It's 1 byte destination, it is copied into 1. No, I want to copy from var1 to var2. You can do it memory to memory, but you're copying into DH, which is a register as a temporary location. Then from that temporary location, you're going to go and copy into var2. So from that temporary location register, you're going to copy into var2, no problem, because it is copying from a register into a memory, no problem. So let's rebuild and see that if I'm right. Yeah, it works. So how can I see what happened? Well, you're going to go to debug and say that I want to debug. Now you're going to go follow. If you don't see this registers in here, you're going to go and say debug Windows. I want to see the registers. So that's what you're going to do. So it is going to copy from var1 into DH. DH is this portion. The first portion, which is 05, is DL. It is DH and the rest. What are those values that are the garbage? Because I don't know how they are produced. Randomly, computer has to put values in the memory. Memory cannot be empty. We don't have the concept of memory, empty memory, because it is hardware. There's no way it can be empty unless if it is off. There's no electricity. So I'm going to go on debug, start debugging. I am doing it. And see this arrow. Now I'm going to go a step over. So this instruction has been executed. The result is going to be in DH. What is the value? It is 2. It's going to be copied to in the memory. If you go, you see that this is, I'm sorry, FC is going to be copied into DH. Oh my goodness, FC is copied into DH. And from DH to var2, can I see inside variable? No. As you see, indeed, this only shows the registers. So how can I see inside the variables? You're going to go into Windows again and say that I want to see watch. You can see what you can watch variables. So I can say that I want to watch var1. I typed in here var1, in here var2. Really, I don't want to see AX. I only want to see DH. So you can see that, well, I don't need this portion in here at all. So I do not need it. So here is in var2 at this time, it is initialized with 0. So let's move it. If you want to move again, you're going to go to debug and say that step over again. So it is going to move. So var2 is going to have a 2, 5, 2. So what are those values? I do not understand. So in order to say that I want to see them in hex, so you're going to say that hexadecimal display. So you go and say that, well, I want to see hexadecimal display. All in hexadecimal. I don't know what I did, I'm sorry. So I say that hexadecimal display. So it is in DH, you copied with FC, then FC is copied into var1, and DH value is copied into var2. I don't know if I said it correctly. So FC is the value currently. You can do the same thing for different types. So I'm going to explain one more type, and the rest you can study the text book. So you can have word size, or you can have double word, which is 4 bytes. So I can have a value which is 4 byte. FC is 1 byte. So it is 2, 3 is 2 byte. 3, 7, 6 is 3 bytes. And ED is 4 bytes. 1, 2, 3. We have to count. It has to be 1, 2, 3, and 4 bytes. So var2 has to be, if you want to copy inside, it has to be double word. When you're using a temporary register, it has to be of the size double word. So you can't use EDX. You have to use EDX. And from EDX into var2. So let me go and see, run my program again. So I'm going to rebuild. Oh, everything is good. And then I'm going to go and do this. I will run this code step by step. So start debugging. But I have set both the variables, watch, and I can see their registers. So the first step, var2, is going to be copied into EDX. So what is var2? That strange number that I produced. So it is debug. I'm going to go and step over. So EDX is going to have the value of FC2376ED. Well, what is in here? It is EIP. IP stands for instruction pointer. So it shows the address of the next instruction. That is the address of the code in the memory of the code which has this arrow. So that code in the memory has the address of 00401016. This is the address of the next instruction. So if I do that one, by the way, in the second operation, the value in EDX, which is this strange value, is going to be copied into var2. So in var2, you're going to see this value of FC2376. Well, there is no use of EDH in here. So I go and rename it into EDX in order to see that really what is there. So I'm going to go on and move forward. And you see that in var2, now you have FC2376. One thing that you have to understand that some of the registers are not readable and writable. So let's do this. I want to copy into, oh my goodness, IP. IP is also instruction pointer, is a register. Can I do this? EIP. And from EIP into var2. So let's do this. But you can see that IP or EIP instruction pointer register is protected. You can't watch it, you can read it, you can write into this. So let's do this, which is rebuild. Oh my goodness, you're going to get an error. It is not writable. So, okay, it is not writable, don't worry. So I'm going to go and see this. I want to see that if I can write the value in the IP into var2 or even a register. So let's say EAX. From EIP into a register. So let me see that if I can do it. Well, I'm going to go and build, and you're going to see that it gives you an error. No, EIP is not readable. You're not able to read its value into a register. No, maybe it is a memory location. So let's say if I can put it in var1, you can see that error. You can't do it. So it is not readable, it is not writable. It is only the address of the next instruction. So it is not. I can't do it. Well, is this only a register with this property? No. There are some registers that we don't have the right to write into. So let's say one of them, it is called as data segment, which shows the address of the beginning of the segment, which is the data segment in the memory. So let's put in here the value of, well, DS is 2 bytes. So I'm going to go and put 2, 3, 4, 5, a hexadecimal. No problem. 2, 3, 4, 5 is 2 bytes. DS is 2 bytes. So let's see if it works. You're going to see that it gets error. The memory address is produced by your operating system. It is not under your control. So if I run, you can say it is an error. No, you can't do it. How about if I want to read that value? So let's go and do this. I want to write it into here. So let me have AX, and I want to write the value in DS. I want to read it. I want to see that if it works. So let's rebuild. No problem, I can read it. So let's go and debug. Let's move one line. So I want to see that what is the address of DS. So it goes into AX. You understand that AX is this half of EAX. So let's do it. So I'm going to go and step over. Good. It is this value 002B is the address of DS. So is there any other register with this property? Yes, those 16-bit registers, which is one very famous one is SS, which is stack segment, has the same property. So I'm going to go and rebuild. It works. If you want to see that, what is the value? So I'm going to go and debug. And then I'm going to go and do this, which is I am going to step over. So you see that in AX, I have 002B. How about if there is another segment so far, data segment, stack segment. So I'm going to show you this code segment, which is another segment. So if I build, yeah, it works also. If you want to see that, what is the value? First, you have to debug, and then when you are debugging, you have to move into a step over. You can see that it is again this time it is 0023 instead of B. So those are not, when we say that, they are not, so they can't be destination. So if I change this code segment and I say that, well, I want to write a value, so let's say it is 0F31E hexadecimal. Well, it is a number because it starts with 0. So I want to write this one in this location. You can see that I get an error. So I'm going to go and stop debugging, or I can do it both in one operation. No, it can't be. Code segment, it is defined. The value, it is initialized by operating system. It is not under your control. You can read its value. You can see that what is the value, but unfortunately, fortunately, you can't write, because if you can write, then you can change the memory segmentation of the memory hardware on your computer, and it is problematic. Well, I have to stop this one